Welcome to the session, the architecture of network firewalls. Imagine you are the IT manager of Discensys Technologies, and today 500 employees are working. Company website is live, customer data is stored internally. Everything is running smoothly. Then suddenly, one morning, thousands of unknown visitors start trying to enter our company network. Should we allow everyone inside? No. Exactly, we need a security guard. And this is where firewall enters the story. Now, let me introduce Raj. Supposing he's a security guard, and every request arriving at the gate is checked. This says he is, I want to enter. And firewall asked, who are you? So, in the same way, the intelligent gatekeeper, that is Raju, who is actually playing the role in the real life, is actual, I mean, is actually technically involved in this way. That without a barrier, systems face unauthorized access and continuous scanning. So, without a barrier in the sense, without a boundary or limit, systems face unauthorized access and continuous scanning. Every single packet must pass through a singular checkpoint, that is one checkpoint. The firewall forces order upon chaotic external environments. You could also try to understand this through the image displayed here. Now, suppose Raja receives a package and looks at the sender, the receiver, the contents. Right. This package is called a packet. Now, packet structure becomes meaningful because Raj needs information to make decisions. Is it right? Yes. Because every information or the maximum information that you have, the maximum understanding you get upon anything, any concept. In the same way, you can understand here, all network data travels in segmented chunks, that is, into divided parts. Right? Traditional evaluation on a looks at the routing envelope. The firewall decides based on origin, that is the source, destination, where it has come from, and transport protocol. And suppose Raja receives instructions. For example, allows employees, allow HR, block unknown visitors. And in this way, he was actually setting rules. So by the rules, rules are stored as access control list, and logic is evaluated strictly top to down. Right? You could see that from the incoming packet to the rule one, whether it is matching or not is actually validated. If it is, then we do not go to the rule 2. If not, you have to again step into rule 2, whether it's matching or not. And even if it is matching, then we can stop it there itself. Or else move forward and check the next process in that way. So the first match wins and subsequent rules are ignored. Unmatched traffic defaults to a global block. And then imagining again, a visitor enters, and 5 minutes later, he returns again. Now the question is, should Raj ask for ID again? No, he already knows him exactly, and that is stateful inspection. And now the term becomes obvious. So here, the context is playing the main role. You could see the stateless, stateful, and deep packet inspection. Now, why stateless, why stateful, and why deep packet inspection? Let's try to understand that. So, coming to stateless, it is checking headers only without having any memory, and which is very fast but considers only basic security. But coming to stateful, it tracks active connections, not just limited to the headers. Right? It maintains state table also with a moderate speed and ensuring high security. Coming to the deep packet inspection, that is DPI, it inspects actual payload, Payload in the sense it includes the address, it includes all the details of that, right? So with the full application context and computational heavy with the highest security. Now this is what makes the difference with stateless and stateful. And now again, continuing, if Raj maintains a visitor register, right, each and every time the visitor enters and exits, if he maintains a visitor register, he writes or he can write visitor name, entry time, purpose and all. So here comes the concept of session tables, or you could also see the title connection tracking and memory. It solves the amnesia problem of stateless filtering, right? And returns traffic for an established connection which is automatically allowed, and drastically reduces the complexity of inbound rule management. You could see the static table, right? Sorry, the session table or the state table, where it includes the source, that is the origin, and destination where it has come from, the IP address, and the port, and status which is active, which begins from the web server and then to the firewall, where firewall decides whether I have to allow or not, and then it goes to the user. So, moving ahead, now a visitor arrives carrying a gift box, which looks normal outside, and Raj becomes very suspicious. The security scanner checks inside, dangerous files are found and blocked. Now, DPI makes sense, right? So, this is what we can call as X-ray in the payload, which looks at the past, right? Looks past the port to see the true application, whether it doesn't contain any malicious malware, right? It has to check. So it inspects packet contents, not just headers, detects hidden exploitation and malware by passing standard checks. Now again, imagine Discensys has 300 employees and one company address. Then courier arrives, receptionist distributes internally, where receptionist plays a role of NAT, and then suddenly NAT feels natural. So let's understand it technically. The network translator, NAT. Private IP addresses cannot communicate directly with the public web. Now you could understand here the public web are the outside visitors or anyone coming from outside, and private IP addresses are the employees. So employees cannot communicate directly with the outsiders, and here's where NAT acts as a proxy intermediary, that is the role of receptionist. It translates multiple internal IPs into a single routable public IP, keeps the internal network architecture completely hidden. So you can try to understand here from the private IP to the firewall, and then public IP to the browser. Next, again, if one visitor keeps attempting entry again and again and again, then Raj notices unusual behavior. Alarm activates, and now IDS. Then IPS actively blocks him, and the story continues. So, what is happening here? So, coming to the slide, application and intrusion defenses, IDS or IPS. Intelligent alarms scanning for known attack signatures. So, they try to intervene or peep into the process and try to understand whether they are known attacks or unknown attacks. Then comes WAF, which is a dedicated shield for observers against SQLI and XSS. And then comes NGFW, the enterprise hardware, bundling all security layers. You could try to understand one layer after other also, right? You could also try to visualize through the image displayed here. Now, let's try to understand with the building layout, right? See, you can also try to find in the image like the security core network acts as a base layer, and then the internet firewall, and then the DMZ, that is demilitarized zone, and then external firewall, and then untrusted internet. So it is actually acting like a layer, right? A built-in layer. Each product are differently. Now, in the realistic way, you could also try to understand this as a server room, upon that management floor, upon that employee area, and then upon that reception. Or it could be even a reverse format if possible, right? So the DMZ, that is demilitarized zone, acts as an isolated subnet for public facing services. And web servers are accessible to the public but strictly separated from internal assets. And then the 2-tier firewall architecture prevents perimeter crossover. Right. Now, network segmentation becomes intuitive. Right. Now, suppose again, company expands globally. Right. It grabs the global name and fame. Right. Now, employees work from Hyderabad, Bangalore, London, New York, and physical gates no longer work here. Just digital gates appear. And now, cloud security becomes very much necessary. So, getting into it, cloud environments abandon centralized physical hardware, right? Firewalls become virtualized policies applied at the node level, that is the entry level. Enables hyperscalable decentralized security architectures. You could see the AWS security group and Azure network security group figured out here. Now, what if suddenly 50,000 fake visitors arrive and Raj cannot handle them? Building entrance gets blocked. Real customers cannot enter. And now DDoS becomes very much memorable. So you could see the headline surviving the siege. And let's try to understand that. So DDoS attacks overwhelm system capacity, not just logical rules. Now what do you mean by DDoS attacks overwhelming? Right? So DDoS attacks become very heavy such that the system's capacity even cannot tolerate it, right? So not even logical rules. Then rate limiting caps the maximum request per second from a single IP, that is tries to track and hold. Then geo-blocking drops traffic originating from high risk regions, right? In order to maintain the traffic in a uniform way. So geo-blocking drops the traffic originating from high-risk regions. You could also try to understand from the image displayed here, which is actually very realistic. Now, suppose management accidentally tells Raj, I love everyone, right? So it is asking to I love everyone. Now, even the best security guard fails, right? So these are the vulnerabilities in the implementation. Vulnerabilities in the sense, the fallbacks, right? So the unused open ports increase the attack surface, right? And overly permissive rules bypass security architecture. And missing firmware updates leave the gatekeeper exploitable. So you could see in the image from inbound traffic till the port 22 SSH open, right? The port is open in the sense unused open port and which is actually leading to very high risk. So who remembers the company story here till the end? Okay, let's try to recap as well, revise while mapping. So here the firewall, which is acting like a security guard in real life, and the stateful, that is acting as a visitor log, and NAT, that is receptionist of Discensys, and DPI, that is as a X-ray scanner, and WAF, they are the property. So the firewall decides who enters based on structural rules, and stateful remembers active connections via state tables, and NIT translates private IPs to public routing proxies, and the DPI inspects the actual payload bypassing port assumptions, and the last WAF protects specific web applications from code exploits. Today, we didn't learn firewalls. We learned how a company protects itself from digital intruders, right? That is the foundation of modern infrastructure and understanding it. Firewalls fundamentally enable safe internet connectivity. They form the bedrock layer for all modern digital systems. Without intelligent blueprints, direct exposure means immediate compromise. And the same method works for wireless communication also. Instead of frequency, modulation, MIMO, and beamforming, let's understand with the story. Ananya in Hyderabad wants to send a photo to her friend Rahul in Mumbai, right? Here, every slide becomes very important part of a journey. Coming to modulation, how does a phone place the photo onto a radio wave, right? That's an important question to be understood. Then the antenna, how does a phone launch it into the air? Again, that is very precious. Frequency, which invisible road does it travel on? Right? Frequency doesn't travel on any road physically, right? So, which invisible road does it travel on? Like, how does it travel? Then the cellular tower, where does it go first? That is also very much important. Handoff, what happens when Rahul is traveling in a train? Coming to MIMO, why can thousands of users communicate simultaneously? How does it happen actually? Beamforming, how does the tower focus signals toward Rahul? Then the satellite. What if Rahul is on a ship in the ocean? Right? Rahul could be anywhere. In the same way, what if he's on a ship in the ocean? And that is the journey of one photograph instead of 15 unrelated networking concepts. Thank you.